I had question number 14 for problem set 10. It reads, a triangle has vertices 0, 0, 6, 7, and 4, 8. What is the tangent of the angle at the vertex 6, 7? Okay, so the first step here, what I did was I went ahead and plotted all these points. So you have your 0, 0 point. You have your 6, 7 point. 6. And you have your last point of 4, 8. Okay, then I went ahead and made a triangle right here, since they say that it forms a triangle. And the first thing I did was I went ahead and solved for the lengths of all these sides. So I went ahead and did Pythagorean's theorem for each side. So right here you have your height of 7, and here's your length of 6. So then this side right here is going to be h squared equals 6 squared plus 7 squared. H squared equals 36 plus 49. 36 plus 49 is going to get you 85. So then h equals the square root of 85. Same thing for all the rest of the sides. Go ahead and just do this. So we have a height of 1, so 1 and 2. 2 squared plus 1 squared equals h squared. 4 plus 1 equals h squared. And then 5 equals h squared. Square root of 5 equals h. And then also, what this problem's asking for is asking for the tangent of the angle of the vertex at 6, 7, which is right here. So we're solving for this angle. And then this last side right here, finish up. It has a length of 4 and a height of 8, so 8 squared plus 4 squared equals h squared. And that's going to give us 64 plus 16 equals h squared. And then, so 80 equals h squared. H equals the square root of 80. Okay, and then once we have all those lengths right there, what we can do is we can actually do the law of cosines. So what we're going to want to do is we're going to use, so it's going to be c squared equals a squared plus b squared minus 2 times ab cosine theta. So what we're going to want to do is solve for cosine theta since we have all our lengths here. So we're going to, since we're solving for this angle, this is going to be c. So we're going to have the square root of 80 squared equals the square root of 85 squared plus the square root of 5 squared minus 2 times the square root of 85 times the square root of 5 cosine theta. So now once you square all these numbers, they just become regular. The square roots eliminate, so 85 plus 5 minus 2 times the square roots of everything still. So then what you're going to want to do is you want to subtract over the 90 right here. So this was at the 90, so you get negative 10 equals negative 2 times the square root of 85 times the square root of 5 cosine theta. And then you're going to go ahead and divide it by that to get cosine theta. So cosine theta equals negative 10 divided by negative 2 times the square root of 85 times the square root of 5. And when you simplify this, so the negatives are going to cancel and you can divide it by 2. So cosine of theta actually equals 5 over the square root of 85 times the square root of 5. So with us having cosine of theta, we can go ahead and set up a right triangle right here and make this condition true. So this is your theta. This could be adjacent over hypotenuse, so 5 over the square root of 85 times the square root of 5. And we're going to want to solve for this length here. So we're going to have 5 squared plus y squared equals the square root of 85, square root of 5, all that squared. So then when we do that, we're going to need 85 times 5 equals 25 plus y squared. Y squared, 25 plus y squared is going to equal 425. And then you subtract your 25 over, so y squared equals 400. And that is going to be y equals 20. So then your triangle now looks like this. 5, and then this is where this angle still. So you want to do the tangent of this angle. So your tangent is going to be tangent theta equals 20 over 5, which actually is just 4. So your answer for question number 14 is just 4.